Okay, class. Now the next topic is data structures in Python. First of all, we need to understand what is data structure. Data structure are a way of organizing data so that it can be accessed more efficiently depending upon the situation. Python support different type of data structure. Data structure means when we organize the data. Why we organize the data? Because of if you want to access the data, once you store the data in the database, and whenever you trying to access the data, so increase the efficiency. Suppose maximum time if you are store the data in unorganized way, so the maximum our time is wasted to access the data. So if you want to access efficiently, or you if you want to access more efficiently, then we have to use the any type of data structure. Data structure are fundamental of any programming language around which a program is built, where we can build a program, and when we build a program, then the fundamental programming language is the data structure. Python helps us to learn the fundamental of these data structure in a simpler way as compared to other programming language. Python support different type of data structures, like for example classification of data structure. First of all, we classify the broadly the data structure broadly into three categories. Linear. This classification is based on the organization of data. If the data is organized in different way, then we can classify the data structure into different category. So we can say broadly there are three type of categories in data structure. Number one is linear data structure. Number two is non-linear data structure, specific data structure. Linear data structure, and non-linear data structure, and specific data structure. There are three type of data structures on the basis of their organization. Linear data structure or linear data structure, we can say. These are the data structures which store the data elements in a sequential manner. As named in the linear data structure or linear data structure, the data elements. Sir, what is the element? Data element. You can say the data structure contains the data in the form of data elements, and every piece of data, every small piece of data is known as element. So if the data elements are arranged in the form or in the sequential manner, then in a line pattern, then it is known as linear data structure or linear data structure. Some example, basic example for this: array. It is a sequential arrangement of data elements paired with the index of the data elements. Array is a collection of data, as you already uh, learn about array. Array is a collection or sequential arrangement of data elements. Linked list. In each data elements contain a link to another elements along with the data present in it. Stack. It is a data structure which allows only to specific order of operation, like LIFO, last in first out. In the stack, we put the last inserted elements deleted first. That's why it is known as LIFO property, or we can say it work on LIFO property. LIFO means last in first out. The next one is queue. Queue is the similar as a queue. Queue means a line. In the queue work on FIFO property, first in first out. If you on front of the queue, then whenever service is provided, then the front person uh, get the service first, and then second, and then so on up to last. It is similar to stack, but the order of operation is only FIFO. It means it works on first in first out. Whoever the come first get the services first. And the second one is matrix. If we array is either in a left to right pattern or up top to bottom pattern. But if you want to use, or if you want to work with the two-dimensional structure, like row and a combination of row and column. In this case, we can say, or we can use the matrix. Matrix, it is two-dimensional data structure in which data elements is referred by a pair of indices. Indices means it is not accessed by a single index. It is always accessed by the pair of indices, that is the pair of the combination of row and column, the combination of row and column by which we can access the elements of matrix. Non-linear data structures, there these are the data structures in the non-linear data structure which there is no sequential linking of data elements. As named mentioned, there is no linear pattern or there is no sequential pattern. All the data elements are randomly stored, and we can pick or we can access data elements in any sequence. There is no specific or strict sequence followed. Any pair or group of data elements can be linked to each other and can be accessed without strict sequence. So in the linear data structure, we can access data element from anywhere, not in a particular sequence. But in the linear data structure or linear data structure, we can use or we can access data elements one by one, not random pattern. When we can access data elements one by one, so this type of data elements is known as linear, and if we uh, follow no sequence, then it is known as non-linear data structure. Some basic examples of non-linear data structure: binary tree. It is a data structure where each data elements can be connected to maximum two other data elements, and it starts with the root node. Heap, in the binary tree, all the data elements are connected maximum to other data elements. The binary tree is a hierarchical structure in which data elements are present in the leveled structure: first level, second level, and third level. Root node is always present on the top, and it is uh, considered as a starting point of a tree. Heap, it is a special case of tree data structure where the data in the present parent node is either strictly greater than or equal to the child, or strictly less than its a child node. The heap is basically classified into two categories. One is, as mentioned, one is minimum heap or maximum heap. If the parent node is strictly greater than the child, then it is known as max heap. And if the parent node is less than the child node, then it is known as minimum heap. It is basically are generally used to uh, arrange the data in either ascending order or descending order. That's why we use the heap data structure. Here's table. It is a data structure which is made of arrays associated with each other using a hash function. It retrieves values using key rather than index from a data elements. In hash table, we we access. It is a similar to array. Array is also table of elements, and arrays hash table is also similar as array. But in the array, we use index for accessing or retrieving all the elements, data elements. But in the hash table, we retrieve values using keys rather than index from the data elements. The next one is graph. It is an arrangement of vertices, and graph is a collection of vertices and nodes, or vertices and edges. Edges is are the connection between vertices. Vertices means data elements on which the data is stored, and each and every node is connected to other nodes. The connected nodes to each other through a links, and links in a graph is known as edges. So we can say a collection of vertices and edges or links is known as graph. Specific data structures. Every language support all these three type of data structures: linear data structure, non-linear data structure, and specific data structures. Linear data structure definition and the type are mostly same. Non-linear data structure and the definition and types are mostly same in all the languages, any type of language. But the specific data structures are the specific to particular language. It is change according to the language. So with the Python language, these data structures are specific to the Python language, and they give greater flexibility in storing different type of data and faster processing in Python environment. It means these type of data structures only supported and provided by the Python. It These data structures are not supported by other language. You can say other type of data structure like linear data structure, non-linear data structure may be supported by other languages, but the specific data structures are not supported, strictly supported by or strictly provided by the only by the Python language. Some basic examples, some fundamental examples of the specific data structures are: list is named. It is similar to array with the exception that the data element can be of different data types. In the array, we can store only similar type of data elements. We can say in the array, in linear data structure, array can contain only the similar type of data elements, but in the list, if you want to create different data types, suppose for example, the if you want to make a collection of items, if you want to make a list of elements in which the first three elements are numeric type and other three elements are any character or string type, then we can use list. If we use array, the arrays support only similar type. If we need to create numeric data elements, then we need to create a numeric array, and if you go for string data elements, then we need to create. It means if you want to create different data items, then we need to create two different array. But in list, we can create a single list with different data types. You can have both numeric and string data in a Python list. As I explain you, in the list we can store or we can create, we can hold, we can keep different type of data elements like numeric and string both. Tuple. Tuple are similar to the list. Here we only mention the definition. In detail we discuss further. Tuples are similar to list, but they are immutable, which means the values in a tuple cannot be modified. They can only be read. It means in list we use different type of data elements, as well as we can add, we can delete, we can remove, we can update any data elements. But in the tuple, once you create the tuple, it is immutable. Immutable means unchangeable. Once it created, it only be read. We cannot modify or we cannot change after creation. Set. Mathematically, the next one is set data element or set data structure. Mathematically, a set is a collection of items not in any particular order. In the the set is also collection of items. But in the tuple, in the list, there are specific this order. But in a set, there is no specific order or no particular order. A Python set is similar to this mathematical definition with the below additional. It means the Python set is similar to mathematical set, and set is different with the particular order is not followed in a set, but the order ordered list, or we can say sequence of elements, first, second, third, like that. We follow in the list and tuple, but set is not follow the particular sequence, particular order. You can say the data elements, when we access the data elements, it may be random pattern. The dictionary, the next one is dictionary data structure. The dictionary contain key value pairs as its data element. In the dictionary Python, this data structure is very important and very commonly used data structure in Python, because of it is index free. Set is also index free. There is no index. That's why the set is not use any particular order, but dictionary have user defined index. You can create in the list and tuple. We cannot create the index in the list and tuple. Automatically computer or compiler create the index start from 0. But dictionary and in the list and tuple, we can say in the list and tuple always the index is in numeric form. But in the dictionary, suppose if you want to create non-numeric indexes, then we can use dictionary to use, and we can define a key as a non-numeric, and we assign value with this key. Whenever we need this value, we can access the value with the help of key, and keyword as a index in dictionary. So we can create either numeric type of key, or we can create non-numeric type of key, textual key. So we can say in the dictionary, in the Python dictionary, we can create any type of key with the help of, but the key value is always unique in dictionary. We cannot repeat, or we cannot duplicate the key value. Value may be duplicate or value may be same, but the key pair, key value is not duplicated. Now we discuss all the specific data structures. The common data structures like linear and non-linear data structures, not uh, elaborate more, but the specific data elements or specific data structures are explained one by one. The first data structure is Python specific data structure is Python list. The list is most versatile data type available in the Python, which can be written as a list of comma separated values. We can create list, we can create a number of items with the list, and all the items are separated by the comma. Each item separated by other items with the comma separated value. Between square bracket, the list is always how we can identify and how we can recognize there is a list. So if any number of values or any different values are put together with separated comma separated in between the square brackets, then we can say this is a Python list. Important thing about a list is that items in a list need not be of the same type. It means already I'm explained you, the list can contain different type of data elements. So it is never necessary or never mandatory the all the elements or all the list items are the same type. It may be different type and maybe same type. Creating a list is as simple as putting different comma separated value between square bracket. It means if you want to create a list of different values, then you can create just comma separated values between square bracket. Example, you can see the example. There are three lists I created. One is number one physics, chemistry, these two values are string type. That's why we put into single quotation. And 1997 and 2000, these values are put it into not put it into single quotation because of these values are numeric value. So list 1 contain different type of values, two values as a string type and other two values as a number type. List 2, the second list, also created with 5 elements, but the elements are same. It means all the elements are number type 1 2 3 4 5. They separated by comma and all 5 elements are put together in a between the square bracket. Next, list 3. List 3 is also created with 4 items, list items, but created with a single alphabet or single character. First character is A, B, C, and D. All these 4 characters are elements, and all these characters are same. All these characters are same. It means the the type of the element is same. That is character. But here the example in the all three examples we mention all three type of values. It means first we create mixed type value, different type of value. Second, only numeric value, and third, only text or string values. Now the second thing is, sir, we can create the list with the square bracket and comma separated values, but how we can access, how we can use the item or elements of list. So similar as an array, we can access, we can retrieve all the data elements with the index. So accessing value, the next topic is accessing values in list. How you can access the elements of to access values in list, use the square brackets for slicing along with the index or indices to obtain values available at that index. It means if you want to access the second element, that is chemistry, the first one is list. In list 1 contain 4 element. One is physics, another is chemistry, the next one is 1997, and the last element is 2000. Suppose for example if you want to access chemistry, then you have to use the index. And as I mentioned previously, all the elements of list automatically indexed, and always index start from 0 and goes up to n minus 1. Here is n is the total number of elements. Suppose in in the list 1 there are 4 elements, then the index of physics is 0, the index of chemistry is 1, and increasing 1 by 1. The index for 1997 is 2, and the index for 2000 is 3. It means there are 4 elements, but the index number is start from 0 to 3. 0, 1, 2, and 3. Similarly, in list 2, suppose if you there are 70 elements, 1, 2, 3, 4, 5, 6, 7, but the index number is always start from 0. So if we want to access the element 4, the index number for 4 is 0. So 3, we start from 0. The index number for 1 is 0, the index number for 2 is 1, the index number for 3 is 2, and the index number for 4 is 3. So if you write the name of list and in square bracket the index number, then the compiler print or access or retrieve the value at the particular provided index. Suppose for example print list 1 in bracket 0, it means list 1 contain Which element at the index number 0? Physics. So the output, you can see the output. List 0 element is physics. So the print computer or the compiler print the first value of list because of the first index of any list is 0. If you want to access second element, then you can use, in place of 0 we can use 1 because of we want to access or we want to retrieve the second element of the list. Similarly, for 1997, 2000 and up to and last number or last elements. So using this phenomena or using this technique, we can access the elements of or values of a list. Next, updating the values of list. Suppose, for example, if in the list there are different values, like for example, list 1 contain physics, chemistry 1997 to. Suppose if you want to put or you want to update means change. You want to change some value, previous value to new value. This phenomena is known as updating. Suppose your the 1997 is updated by or changed by 2001. Then the value, this operation is known as updation. So how we can update the value? You can update single or multiple elements. If you want to update one element or single element in the list, or if you want to update multiple elements at a time, you can both the operation, we can perform both the operations. But how we can perform the phenomena for single updation or updation of single element, and for updation of multiple elements, the phenomena will be changed, but we can do it. Giving this lies on the left hand side of the assignment operator. If you provide assignment operator left side, then we can change any value, and you can add to element in the list with the append method. Yeah, also suppose there are 5 elements, and if you want to add, if you want to insert a new data items or data elements in this existing list, then we can use append. Append means append any element at the last end. But if you want to change chemistry to mathematics, physics to biology, or 1997 to 2, then we have to use or we can update with the help of index. But if you want to append any value, then automatically by default the appended a newly added value always added at the last. That's why it is known as append. Append means any value appended or embedded at the last. Print value available at index. For example, we mention here a program list equal to physics, chemistry 1997 2000. Print value available at index number 2. Which value is available on index number 2? You can see the 1997 is present at the index number 2. How we can determine the index number for physics is 0, the index number for chemistry is 1, and the index number for 1997 is 2. So if you want to print the value at index number 2, so print a statement, print value available at index number 2, and print the list. List is the name of the list, and in the square bracket we write the index number. Index number is 2. You can see the output this program, the value available at index number 1997, but in the second line we update the value at index number 2 using list, the name of the list, and in the square bracket we write the index number, and equal to sign is used to assign a new value to that element. Now the value available at index number 2 is 2001 2001 because of the new value updated the old one. Again we print the value, and now print new value available at index number 2, and again print the same, the index 2 index value in the list. Then you can see the output value available at index number 2, the previous value is 1997, and the new value available at index number 2 is 2001. It means we can say the new value updated by the old one, or the old value is updated by the new one. So using this phenomena or using this process, we can update or change the old values by the new values in the list. Deleting list element. Suppose, as I already discussed, we can access the element, we can append the element or insert the element at the last, and we can also change or update the value of any element. But for updating the particular element, we need to remember, we need to know the index number of that particular element. If you want to change 2005 in place of 2000, then first of all you need to know the index number of 2000. Once you know the index number, then after you can uh, update the value at index. But now if you want to delete some element, maybe you want to delete one element or more than one element. So to remove the element in the list or delete the element in the list, you can use either the delete statement if you know the exactly which element you are deleting. It means suppose you know, uh, I want to delete 1997. It means 1997. Suppose I know already this element I want to be delete. So first we need to know the index number for this element, and using index number we can use the delete method or delete function, and we can delete the value. But if I don't know what is the index number of 1997, in that case the delete function is not capable to delete the value without index number. In clearly, uh, clear both the things. One is you can delete any element with the help of index number, but for this you have to know the index number for the element. And if you don't know what is the index number for this element, in that case the delete method is not capable to delete that element. So then how we can delete the element? So we can use another method that is known as remove method. In this method we pass directly the value of the index. In the delete method you can see the program list 1 physics chemistry 1997 and 2000, print list 1 print. But we performed delete list 1 2. It means the second index of the list. The index, how we can determine the index? The first, always the first element have index number 0, and the second element have index number 1, and increase one by one up to last. So the index number 2 of which element? You can see clearly 1997 have the index number 2. Delete 1997, and after deleting value at index number, so suppose you print the list physics, first print the list whole list. After deleting 2, it means the second index or 2 index value is deleted. So 0 is physics, 1 for chemistry, and the third one is in 1997. is at the last output, you can see clear cut that the second index value or two index value is deleted from the list. And now after deletion of second element or second indexed element, the list only contained three elements, but before deletion we can see the list contained the four element. So using this method, delete method or delete function, we can delete the element from the list. But again, I will explain you that, and I remind you, for delete a particular element, we need to know the index number for that element. If you know the index number, then after you can delete the element. Now the now the next data structure is Python in Python tuple in Python we can say. As we know, tuple is also a collection of elements, much like a list. But a tuple is a sequence of immutable Python object. It means a tuple is a collection which is ordered and unchangeable. The list, we can say, the list items are deleted, updated, and also inserted new elements in the list. But the tuple is immutable. Immutable means unchangeable. Once you create the tuple, then you cannot change the elements as well as the value of the elements. A tuple is a collection which is ordered and unchangeable. Tuples are written with round bracket. As we know, the list is written in between the square brackets, but the tuples are written same as separated comma separated values in between the round braces. Tuple items are ordered, unchangeable, and allow duplicate values. In list as well, we can use duplicate value, and we can use in tuples the duplicate value as well. Creating a tuple. Now the question arises here that how, sir, we can create the tuples in Python. In Python programming, tuples are created by placing a sequence of values separated by comma with or without the use of parentheses of for grouping the data sequence. It means there is no mandatory condition here. We must have the use parentheses. We can use or without use. We can create a. It is when the value are separated by comma, then automatically by default the tuple is created. The same example I am taking with tuple. Suppose for example, tuple 1 have values in the difference, only difference you can see the difference in only in the brackets. In the list there are square bracket, but in the tuple there are rounded brackets. Simple parenthesis you can see. Tuple 1 have four elements: physics, chemistry, 1997 and 2000. And tuple 2 same values as list 2, 1, 2, 3, 4, 5. In the tuple also we can put different type of values in a single tuple, or similar type of value you can also put. Tuple 3 with, in these three examples, all three type of creating of tuple are mentioned: A, B, C, D, all separated values by comma, but there is no use of bracket. To write a tuple containing a single value, you have to include a comma. Can we create a tuple with single value? Yes, we can create a tuple with a single value, but even the value is 1, even though there is only one value, it means you have to put a comma in after the single value, even though there is only one value. If you have only one value, again you have to put a comma after the single value. Then only it is treated as tuple. Otherwise, it is treated as a simple variable. It is not a list or it is not a tuple. It is a simple variable. So you include a comma. You have to include a comma even a single value is there. The second, accessing values in tuple. Same question phenomena, same question arise here. Sir, once you create the tuple, now how we can access, how we can use or retrieve the elements, the data items of tuple. To access values in tuple, the same phenomena, same process as we mentioned with the list. To access values in tuple, use the square bracket for slicing along with the index or indices to obtain value available at that index. It means whatever or when uh, which one element you want to get, you have to mention the index number in between the square bracket. The name of tuple, you can access the any element with syntax, the name of tuple with bracket or in between the bracket the index number for that value. Suppose for example, if you want to access or if you want to do the chemistry, then you have to write print tuple 1 square bracket and what will be the index number for chemistry. So we can see clearly the first element of tuple is physics. The index number for physics is 0 and the index number for chemistry is 1. So if you write print a tuple 1 square bracket in between 1, then it prints the chemistry. And again we remind you, we recall you, the in the tuple and list we never create the index number. Index number are automatically created in list and tuple, and the index number is start from 0. The first element get the 0 index number and then 1 and 2 and up to last n minus 1. So in the second tuple, if you want to access the element from index number first to fourth or first to fifth, first means 2, 3, 4, 5. You can access in the tuple, we can access and also in the list. Slicing means a small piece of tuple. If you want to access one element, you can access with the help of index. If you want to access more than one element but not a whole list or whole tuple, it means sub part, sub tuple, small part of tuple. Suppose you only want three continuous element, 3, 4 and 5. The index number for 3 is 0 for 1, 2 for 1 and 3 for 2. Index number start from 2, 4 and 5. The 2, 3, 4. There are three index you can print. So if you want to range or slice of tuple, print the slice of tuple, then you can print as print tuple 2 1 colon 5 in between the square bracket. It means it start from 1, 1 is included and 5 is not included. It means 1, 2, 3, 4. 4 elements it prints. You can see the output. Tuple 1, 0. It means which element at the 0 index? The physics located at the 0 index. But if you print tuple 2, 1 colon 5, then print 2, 3, 4, and 5. The 5 have fourth index. It starts from 1 and goes up to 4. 5 is not included. The last value in the range is not included. If you remember, then I already explained you when I explained you the range function with the for loop. Same, this 1 is to 5, 1 colon 5 is similar as range from 1 to 5. 1 is included and 5 is not included in the range. That's why the list a tuple print only 4 element. As you see, there are total 5 elements, but why print only 4? Because of the 1 is included and 5 is not included. Updating tuples. The second thing, how we can update or change. Update means the change. But already I told you the tuple is immutable, which means you cannot update or change the value of tuple elements. So then how we can change? We can not change or update the value, but we can create a new tuple with a portion of existing with tuple. Suppose if you want to create an one tuple and two tuple, and if you want to create new tuple 3 with the help of two tuples, then you can add or you can perform or you can write this code to create a new tuple and print tuple 3. Then you can merge two tuples. You cannot add a new element or update any value in the tuple, but you can create a new tuple from you are able to take uh, read the second point. You are able to take portion of existing tuples to create new tuples as the following. It means if you want to take some portion of tuple from existing one and create a new tuple with the existing portion of the tuple. Print tuple 3, then you can see the output. First, the content of tuple 1 and then the content of tuple 2 are merged together and form create a new tuple, that is tuple 3. Delete tuple elements. Sup As I already told you that the tuple is immutable, it means unchangeable. So removing individual tuple elements is not possible. It means we cannot delete, we cannot remove a single value or single element, individual elements in the tuple. But there is, of course, nothing wrong with putting together another tuple with the undesired elements discarded. It means suppose if you want to remove three elements from the list, you want to take only one, then a new tuple is create with the this one and the old one is delete. To explicitly remove an entire tuple, just use the delete statement. You can delete, you can destroy the complete tuple, entire tuple, but you can't delete or remove a single element, individual elements from the tuple. So if you want to delete the whole tuple, first you need to extract the elements whatever you want from the tuple, and then after delete the whole tuple, you only require the element you have and then create with the date elements a new tuple created. So a indirect way to create a new tuple or indirect way to delete some unwanted undesirable elements. But this is indirect way. Directly we cannot delete the individual elements. Directly we can delete only the whole tuple or entire tuple. You can see the diagram. If you delete the entire tuple and again try to access. After deleting, you are trying to print tuple, then the error message is generated. After deleting, your messages print tuple is not a defined value because of the what you created your tuple created is deleted first. After deletion, you can't get the value. Now we can see the difference between tuple and list. Not difference only, but here is the comparison between tuples and list. I consider both the things, similarities between tuples and list and also differences between tuple and list. The first difference, functions that can be used for both list and tuples. First we discuss the similarities and then we discuss the differences between them. All the functions similar. What is the similarity between tuples and list? Then the similarities with the tuples and list are, we can use length function, maximum function, minimum function, sum function, any, all and shortest. All these functions we can use with tuple as well as we can use with the list. This is the first similarity between the tuple and list. The second, methods that can be used for both list and tuples, count and index. Sir, what is these methods? Sir, suppose if you want to find out how many elements in the list, then you can perform the count. Suppose if you have a string and if you count the number of characters in the list, then you can perform the length method. How many elements in the list, then you, if you are have a numeric list and if you find out which element is maximum in the list and which element is minimum in the list, so we, for this we can use max function for getting the or finding the max value in the list, and minimum function is used to finding the minimum value. Suppose if you want to perform the sum, totaling summation of all elements, all values available in the list or tuple, so you can use sum. Any, if you want to access any, if you want to access all elements, suppose the list or tuple is unsorted order, and if you want to sort it, then you can use the sorted method for to perform the sort. Second, methods can be used for both list and tuple, count, index. You can find index of any element. If suppose if you don't know what is the index for that particular value, so with the help of index function, with the index method, we can get the index number of any available element in the list or tuple. Both list and tuple both are support and both use the index method. Tuples can be stored in list. It means if you have a tuple and if you want to create a list with the help of tuples element, it means you want all the elements of tuple into list, you can create. Tuples can be stored in the list and list can be stored in tuple, vice versa. If you want to create a tuple with the existing list, and if you want to create a list with existing tuples, both are created with each other. It means you can create a tuple with the list and we can also create the list with the tuple. Both tuple and list can be nested. It means nested means a tuple within another tuple and list within another list. So tuple and list both are can be nested. Both can be nested means both are have another tuple and another list within a list. Differences. Now the differences. Methods that cannot be used for tuple. It means append, insert, remove. pop, clear, sort, and reverse. These methods are not used with tuple. These methods are only used with the list. We generally use tuples for heterogeneous different data types and list for homogeneous similar data types. If you want to create similar data elements, collection of similar data elements, then you should go for list. And if you want to create heterogeneous or different data types or different data elements in a single list, then you can go for, or you should go for the tuples. Iterating through a tuple is faster than a list. It means iterating means accessing of element one by one. When you access the element from first to last, then the tuple is faster. We can say tuple is faster than a list. We can say the tuple is faster because of the tuple is immutable and the list is mutable. That's why the tuple is faster. Lists are mutable whereas tuple are immutable. It means we can change, update the value of any element in the list, but we cannot change the individual values in tuples because of the tuples are immutable in nature. Tuples that contain immutable elements can be used as a key for a dictionary. So tuples are immutable. We cannot change the value of the tuples are elements of the tuple. So we can use, this is the futuristic point. If you want to use the element of a tuple in as a key in the dictionary, so you can do this.